Good morning, students. My name is Teacher Mark. I'm your science teacher. Let's review our lesson yesterday. Yesterday, we studied about kingdom Protozoa. And we studied about the general characteristics. Here, in number 1, any organism not classified as a plant, animals, fungus, or bacteria, they are prokaryotes. Here, in number 2, protists are eukaryotic, having a distinct nucleus and organelles. Number 3, most protists are unicellular or one cell, but some are multicellular. Let's go to number 4. For number 4, protists are primarily classified according to how they obtain nutrition. Letter A, animal-like heterotrophs. We have example here, paramecium. They are eating other organisms. Letter B, plant-like or autotrophs. They obtain chloroplast and make their own food using the process of photosynthesis. And A, fungus-like, they are decomposers for heterotrophs. Let's proceed. Now let's proceed to animal-like protists or protozoans. Number 1, method of movement. They have cilia, hair-like projection used for movement and feeding. Letter B, we have cytoplasmic streaming. So they have false foot extends and cytoplasm streams into it. These are an example of this one. And number 2 is paramecium. These are the pictures of paramecium. They are eating other organisms. Contractile vacuole collects or removes exist water molecules, maintain homeostasis. Here you have nucleus here, and then you have cilia here, and oral groove and cell membrane. Number 3 is amoeba. So amoeba is like this picture here. They have false foot to move, and they have nucleus in the center. Contractile vacuole also here. You see this picture. Okay, so let's watch some video about this microorganism.
There are eukaryotic creatures with a single cell, living in the soil and the water as well. Microscopically they're bigger than bacteria. They all are protozoa. They all are protozoa. They can move with flagella. They flick like whips, or with waving cilia that let them go on trips. Others use feet called pseudopodia. They all are protozoa. They all are protozoa. Some of them are parasites that can cause disease, such as malaria and amoebic dysentery. Others are quite harmless and just want to be left alone, living free. They have an active feeding phase, but they can desist, becoming inactive for a while as a dormant cyst. And they can wake up again if you insist. They all are protozoa. They all are protozoa. They derive their nutrition from organic matter eating other organisms until they get fatter. And when it's time to reproduce, they can make new protozoa simply by dividing into. They all are protozoa. They all are. They are protozoa.
Naturally to our eyes, which is, we think, why we've had several people ask us if our footage is sped up. But no, unless it says so on screen, all of our clips are in real time. These little folks can just move. And they need to move to search for food, to avoid predators, to get into or out of sunlight, to move toward chemicals they need or away from chemicals that poison them. And the wild thing is, with all the diversity of microscopic life, single-celled eukaryotes basically all move around in 3 or maybe 4 different ways. How organisms move is so important and so obvious when they're observed that protozoans, which is the general name for single-celled eukaryotes, are actually loosely classified by their style of movement. We've got ciliates, which move using cilia, flagellates, which move using flagella, and amoeboids, which move using pseudopodia. Oh, and then there's pseudopodia. We're going to start with the shapeshifters of the microcosmos, amoeba. These cells can change their shape as they wish, allowing them to extend parts of themselves into features called pseudopodia. These extend in the direction they want to move and then solidify as the cell moves into the newly occupied space. Pseudopodia is Latin for basically false feet, and these extensions, which are half reaching arm, half cell body, are how these crawlers move and hunt. The secret here is that the cytoplasm of an amoeba can be easily changed from a fluid state into a solid state and back again. When an amoeba moves, liquid cytoplasm flows through the center up to the tip of the pseudopod and then gushes to the sides, where it becomes more of a solid gel, allowing the cell to lock into its new location. Predatory amoeba create these extensions in all directions to trap prey between them. Once the prey organism is surrounded by the pseudopodia, the amoeba simply swallows it. The 2 other main mechanisms of eukaryotic movement, cilia and flagella, are more common, and they're actually really similar, both functionally and structurally at the molecular level. Though they look like rods sticking through the surface, they're actually extensions of the cell membrane wrapped around rigid tubes called microtubules that are anchored in place. However, hydrodynamically, they're very different. There are usually an easily countable number of flagella per cell, whereas ciliated organisms have huge numbers of cilia. The word cilia actually comes from the Latin word for eyelash, which makes sense as you can sometimes see them ringing a cell as our eyelashes ring our eyes. But in those cases, the cilia actually often cover the entire cell. They're just harder to spot against the background of all the stuff on the inside. Cilia move organisms by beating in waves over their surface. A cilium, which is the singular of cilia because Latin, has only 2 possible positions. During the effective stroke, the cilium sticks out perpendicular to the cell, and during recovery, it folds back towards the cell's surface. In most ciliates, the cilia are arranged in rows, and the cilia of a row don't move all together at once. When some of the cilia are in the effective stroke, others are in the recovery stroke. And in some ciliates, you can see the wave pattern this creates. And these waves are basically grabbing on to the sticky, viscous water, yanking the cell through. One added complication here, some ciliates have dense bundles of cilia called cirri. Cirri are used to walk on a solid substrate rather than pulling the organism through the water. Though it's the same structure, it is a bit of a different system of movement. Now, on to eukaryotic flagella. The motion of most flagella is characterized by this long, wave-like beating pattern beginning from the base of the flagella and moving out to the tip. This is Facus longicauda. We recorded this footage in phase contrast, which makes the transparent parts of the cell more visible so you can see the beating flagellum better. Can you see it at the tip of the cell? Facus longicauda is a photosynthetic flagellate. It uses sunlight to produce sugar. You can see the chloroplasts in the cell like green peas, and the round transparent part in the middle of the cell is a starch-like carbohydrate storage unit called paramylon. Now, of course, as always, the deeper you look, the more confusing and amazing things get. Diatoms are sometimes completely non-modal, but some species can also move by excreting mucus through their cell, slowly propelling them over a sub.
Hello students, let's proceed to our next activities. So for our activities, teachers send a PDF. This PDF is about articles on kingdom protists. Now you're going to highlight the important points. So there are two important points here. One is for name and one is for the keywords. So example, let's highlight organisms. So organisms name, and then let's highlight also a keyword like this one, okay? So you're going to highlight name and also highlights for, this one is for the keywords, okay? Keywords. Okay, so this is your work, and then you can send to line or send to teacher Patricia. So thank you so much and have a nice day.
They all are protozoa. They all are. They are protozoa.